Hey guys, welcome back. And let's just start from where we had stopped last time in the last video. So basically, we are moving on in the JavaScript series. And right now, we're going to look at a very interesting and very powerful feature of JavaScript. Okay. So let's just start. So let me just save this as a new file called okay. Now let me do something over here. So just to recap very quickly, we saw global variables and we saw local variables, right? And we did see that we can even create the same name variable in the global and the local, and they actually do not collide with each other, right? So basically, um, that was how the local scope and the global scope were being honored across the page, right? So let's see how this can be extended further. Okay. So we will look at something called nested functions. Okay. Now, previously we have seen that JavaScript can actually uh, have functions which uh, operate on functions as well as take the functions as parameters. Okay, and those are actually that feature of JavaScript is called higher order functions for information. Okay, but anyway, we are not doing that right now. We are now trying to concentrate on is nested functions. And this is also where you will have to just recall our self-invoking functions. Okay. So we will also use that over here. So now just let me take out all this unnecessary stuff. Okay. So we took out all the unnecessary stuff. Now let me just let's say that this is a normal function. This is not even a function expression. Okay, this is just a normal function. And what we will do also is that that part will be still helpful for us, so we will just keep it like this. Okay. So now let's just try to do something over here. So let's just put this, and this is where our nested function is coming into picture. Okay. Okay. So now if you see over here, we have a function inside a function. Okay. And there is a console log inside this function as well as outside in I mean in the okay, let me just make it more precise. Innermost. Okay, so that way we have one in the innermost function, one in the outer function, and one outside all in a global scope. Okay, or maybe I'll write it in a better way: inner, outer, and global. Okay, that will be better. So now let's try to see what this gives us. Okay, so this is we still need to execute the function. So let's just have a name for this, because this is not a self-invoking function. Or let's do this, where fn equal to, okay, and we can even write this fn one equal to, okay, and over here we still need to call fn. Now for this case we don't need the parameters, so I'll just, so this function is no more returning any value. Okay, so I'll just call fn, and let's see what happens. Okay, so now what do we see? We didn't get any error, which means JavaScript does support nested functions. But what happened? We got outer 9 and we got global 8. So this inner function did not execute, but the when we called fn did execute, and it printed out outer p4, and in this case it's 9, which means that it got whatever scope it was inside that particular function. And so this was basically the local scope. Okay, and outside global, there it got 8, which is the global scope. So actually there is nothing new over here so far. Okay, Now let's try to change this a bit. What we will do over here is we will make this self-invoking. Okay, and now let's see what happens. Okay, so there's an issue over here. Let's just see. Okay, so actually let's take out this one because now this is anyway self-invoking, so we will make it like this. Okay. Yeah. So now the self-invoking function is in is running basically. Okay. Now what happened over here? Inner P4 has actually worked, but which is the scope that this has taken? It's taken 9, which means it's the local scope of the most nearest function above. Okay, so earlier we have seen that JavaScript supports uh, like each function can only look at the scope which is above it. Okay, in that page, and this actually goes ahead in a way that it just looks at something at the most nearest to the furthest. So basically first it will look at this line and then it will look at this line to see wherever it gets a P4 declaration, and over here it got something in the outermost function, which is basically the fn, and so it printed P4. Now let us try to do one thing. Let's just take out this. So now you don't have a P4 in the function scope. Okay, so now let us see. And if you see here, it has taken the global scope. So it's just like this. I will look at something above me, okay, and I'll start looking from the bottom to up, and whichever I'll get, I'll just treat it the scope. So if I get a function scope, I'll treat it as a function scope. If I get a global scope, if I don't get a function scope for that matter, then I'll take the global scope if it is there. Okay, so that's the way this is working, guys. Okay, and this is again very important to understand over here. And so far we have not introduced any new feature as such, but still uh, we are observing a very interesting thing, and this is again like very powerful also. Even the power of nested functions itself is going to be very useful. Now, why the power of nested functions will be useful, let us just see. For that we'll take a scenario. Okay, so I have a new example over here. Let's just first of all save this as a new file. Okay. So now what's this? So we are looking at a function expression, first of all, and this is called humus, the function name. Okay. And inside this, we have a nested function. Yes, you got right. You got that right. So inside that, there's a nested function. Outer function takes factor as a parameter. Inner function takes amount, unit, and name as parameter. And what does it do? Inside that, it first of all multiplies the amount into the factor. Okay. Now, where is the factor? So if you consider this, if you compare this with the usual way of the way programming languages work, we have never seen this kind of thing happening, right? Usually, in a typical programming language, what will happen is that you have this kind of function, right? And you may have some parameters over here, and you can also have some local variables here. Okay. And likewise, you can also have another variable here, another function here, another parameter here, and another local variable here. Okay, this kind of thing we have seen, and we can have a global variable here, which is p6, let's say. So this kind of thing we have seen in most of the programming languages. Right? But first of all, we have not seen nested functions. And the second thing is that a function having access to something which is declared, not declared within the function. For example, the factor variable here. The factor variable was not declared inside the function. How will it get it? Right? Anyway, let's park that for now. And by the way, this is using the ES specification, the new ES6 specification let. So I'll just change it to where to make things simple. Okay. By the way, this example is taken from the very, very famous JavaScript fundamentals book that we all refer to for any, and I would definitely recommend for any JavaScript beginner, looking JavaScript. Okay. So anyway, so now once that is done, what happens to ingredient amount variable? So ingredient amount, we then check whether it's one or not, greater than one or not, and depending on that, unit changes. Unit is a local variable under this same scope. And that is pretty obvious. So then we console log ingredient amount, unit, and name. That's fine. And then what we do is we call the ingredient function, which is just defined with all sorts of different parameters, and that all that is happening inside the humus function itself. Okay, so now if we save this, Nothing happens, and that's obvious because we haven't executed the humus function. So maybe what we will do is just wrap over this entire thing. Okay. And over here we can say 5. Let's just see. Okay. Take this out. Okay. So now let's see what happens. What did happen? First of all, we have 5 cans chickpeas. So console log, it's coming from here. 5 is the ingredient amount. Now, what did we pass to amount? 1. So 5 into 1 is 5. Ingredient amount is 5 in this case. And then if ingredient amount is greater than 1, of course it is. So unit becomes units. Okay, so that's why you see oh sorry, unit we have passed as can, so can becomes cans, and chickpeas, right? Now likewise 0.25 is the amount, unit is cup. Okay, so factor is 5 for everybody. So 5 into 0.25, which is 1.25, and that's why you see this cup becomes cups because that's greater than 1. And this is tahini, which is of course the name. This is the name. And that's why you see all this. And just to make matters very simple, I will just take away all of these. Okay, and also to make matters simple, I'll just take away this. Okay, in fact, what I think is for this particular example, you don't even need this. Okay. Yeah. Okay. And now to make things more easier, I'll just say this is outer and this is inner. Make this as inner. Okay, and we have 5. To make this even more obvious, I would just do one thing. I can even make this also as self-invoking with 1. Okay, so just wanted to show that it's not, I mean, self-invoking is nothing special over here. The idea is that it's all about this, right? Factor variable. Where does this factor variable come from? So here's the thing. JavaScript uses something called lexical scoping. So what is actually the lexical scoping? Now this is again taken from that famous book that I have been referring to. The definition of lexical scoping is this: the set of bindings visible inside a block is determined by the place of that block in the program text. Okay, so the bindings, you can just think about it as variables over here. The set of bindings visible inside a block is determined by the place of that block in the program text. So where exactly that block is positioned in the program, that will determine what set of bindings is visible. So if I take that as number 1, then what's my number 2? Is that each local scope can also see all the local scopes that contain it. And this is exactly what is happening over here. Each local scope is able to see all the local scopes that contain it. And all the scopes, so maybe I will just put it over here, the third point, that each local scope can also see the global scope. Okay, and this entire thing is called lexical scoping. Okay, this entire thing is just called lexical scoping. So I hope this is very clear, the definition of lexical scoping. And if you see here, this is exactly happening over here. Now I'll just show the third point. I think the third point is not yet shown over here. So I'll just say where total equal to 100, and then I'll say that or let's say instead of total, I'll say external, and over here we would say that factor equal to, or factor plus equal to external, and over here also we can say that external. Okay, now let's see how things behave. Okay, there's an error over here. Oops. Okay, so I need to just put over here. Yeah, so now I have got 205. Where is this coming from? So we have 100 at the top, we're passing in 5, it's coming over here, and it's going ahead and adding factor to the external. So now we have 100 plus 5 in the factor, which is now 105. Okay, so straight away you see that outer is actually using the global variable over here. Okay, so 100 plus 5 is 105. Now inside of inside of the inner, we are actually using 105 with 1. Okay, so 105 multiplied by 1 plus 100, which is becoming 205, right? So okay, so where is external over here? And in fact, where is external over here? That is where lexical scoping is coming into picture. In fact, if we just check from here, let's say we've put external as 10. Okay, now let's see. You see, it is not visible. It is not visible. Now, let's call outer again with 5 now. Okay, now if this 10 is going in, then what should we expect? We should expect 5 plus 10, 15, and then 15 plus our amount, which is 1. So 15 plus 10 is 25. Okay, so let's just see. Okay, there seems to be a problem over here. Just do a console log. No, there is some problem over here. Outer is not a function. Okay, so right now it is made as a self-invoking one, so just need to take that out. Okay, so as you just now saw, right, that self-invoking functions are executed by their own. You can't just execute them by the name as well. Okay, so yeah, I think this should be fine. Just let me see. Yeah. No, this was the inner one, right? There was no problem in this one. The problem was here. So let's call it over here. Yeah. Now let's see. What's the problem now? This is not a self-invoking one, so this should go away. Maybe I'll just put a semicolon over here. Okay, so first it comes 205, next it comes 25. Okay, now is that obvious by now. So that is what we looked at, right? Where we said that um, it's determined by the place of that block in the program text. So where actually you are putting this, we are putting it over here, then it will not look at this change. If you're putting it over here, then it will look at this change. Okay. Okay. So just one more thing over here. Let's say that, let's talk about the reverse. So we have declared the amount over here, right? Now let's try to see if we can get console log ingredient amount outside. Okay. And this is not defined. Okay. So I just showed you to show that the reverse is not true, which means that an outer function or outer a binding visible inside a binding defined inside a inner block cannot be visible to an outside block. Okay. So you know what, all this while what essentially we have been discussing is the most powerful as well as the most misunderstood as well as the most seemingly complex feature of JavaScript called closures. Okay. So again, taking the quote from my famous JavaScript book, the feature of being able to reference a specific instance of a local binding inside an enclosing scope is called closure. Closure is sort of, you can imagine this is sort of like creating a house. Okay, once you create a house, it's basically something available declared within the house, or built within the house, that's accessible inside the house. Okay, as well as the things which are not built inside the house. So for example, uh, let's just say that you are inside a house. Okay, you are inside the house, your own house, and now uh, somebody tells you to bring a spoon. Okay, let's just say like we are preparing breakfast and everything is ready, and we need to serve the food and we need a spoon, so you've been told to bring a spoon. So what essentially you will do is you just go ahead and look for a spoon within the house. But what if that spoon is not available within the house? Essentially what we would do is you will just go ahead and go, or like come outside the house and just find out the spoon that's been declared, or rather that's available nearest, in the nearest shop in the vicinity of that house. Correct? So you can just think of closures the same way. A function that references bindings from local scopes around it is called a closure. And this behavior not only frees you from having to worry about lifetimes of bindings, but also makes it possible to use function values in some creative ways, which we will see, of course. Okay. So this feature of being able to reference a specific instance of a local binding in an enclosing scope is called closure. And a function that references bindings from local scopes around it is called a closure. Okay. So now let's see the use cases. So let me just give you one more example. So better that I'll just close this and open a new window.